Hello everyone, welcome to our project presentation. My name is Noor Malik, and I am the Backend and Machine Learning Engineer for this AI-powered mental health companion system. Together with my colleague Ghulam Qadir, we built a fully responsive ecosystem engineered to provide scalable predictive analytics for clinical mental health tracking. Quote, "My name is Noor Malik, and I am the Backend and Machine Learning Engineer for this AI-powered mental health companion system. Together with my colleague Ghulam Qadir, we developed a complete full-stack system designed to provide smart mental health tracking and predictive analysis. The main goal of this project was to help improve mental health monitoring by moving from traditional manual checkups to continuous AI-based tracking. In many cases, mental health changes are missed because patients only visit doctors occasionally. Our system helps solve this problem through real-time monitoring and intelligent analysis. As the backend and machine learning engineer, my main focus was to remove simple hard-coded logic and replace it with intelligent machine learning models. Instead of using basic if-else conditions, our system makes predictions using trained AI models and real-time patient data. Now I will briefly explain the project structure. Our GitHub repository is divided into two separate parts, the backend and the front-end. The backend contains all Python files, machine learning models, APIs, and database connections. The front-end contains the complete user interface of the application. During development, we found some duplicate package files in the root directory, so I cleaned the repository and removed unnecessary files to make the project more organized, professional, and deployment-ready. For the backend server, I used FastAPI with Uvicorn. FastAPI is a modern high-performance Python framework that supports asynchronous operations. This means the server can handle multiple requests smoothly without freezing or slowing down the application. For example, when a user submits a journal entry for emotional analysis, the server processes the request quickly in the background while the front-end remains responsive. To make the backend secure and reliable, I implemented data validation using Pydantic schemas. Every request sent from the front-end is validated before processing to ensure correct and safe data handling. When the front-end sends user data, the backend checks the request, processes it through the machine learning models, and returns a structured JSON response containing predicted mental health risk level, detected emotional state, recommended coping strategies. All of this happens within milliseconds. Now let us look at the intelligence behind the system. For the risk assessment pipeline, we trained a machine learning classification model using factors such as age, anxiety levels, stress scores, and panic attack history. Instead of using simple score calculations, the model analyzes relationships between multiple features to predict the probability of mental health risk more accurately. For the text semantic journaling pipeline, we used natural language processing techniques. Traditional systems only detect fixed keywords like sad or depressed. Our system understands the overall meaning and emotional context of the user's text. The model can identify emotional states such as stress, anxiety, depression warning signs, balanced emotional state. I also designed the cloud database infrastructure using Google Firebase Firestore. Whenever a user completes an assessment, the backend automatically stores the results securely in the database. This allows long-term tracking of user history and supports future visualization and analytics features. Finally, we compared multiple machine learning models to select the best performing one. We tested Logistic Regression and Random Forest Classifiers. The Random Forest model performed significantly better. In the confusion matrix results, the model showed very few false negatives, meaning it successfully identified most high-risk cases. In the ROCAUC evaluation graph, the random forest model achieved a score of 0.97, which indicates excellent prediction accuracy and strong diagnostic performance. In conclusion, we successfully built a smart AI-powered mental health monitoring system that combines machine learning, NLP, cloud databases, and modern backend technologies to provide accurate, real-time mental health analysis. Now, I will hand over the presentation to Ghulam Qadir, who will explain the front-end interface and user experience of our system. Thank you.
Thank you, Noor. Hello everyone, my name is Ghulam Qadir, and I am the front-end and system integration engineer for this platform. My core responsibility was to transform Noor's powerful AI backend and cloud infrastructure into a seamless, responsive, and secure user experience. Let's dive straight into the live interface demo. Our application is built using React with Vite for rapid, production-grade module bundling. Here, on the Risk Assessment tab, we have a fully interactive questionnaire component. Watch as I enter dynamic user attributes live, no hard-coded values. When I click Analyze Profile, notice the immediate visual feedback. I implemented async state loaders, risk loading, and journal loading, which safely disable user controls and display contextual loading states while the backend processes the extraction layers. Once the fast API model responds, the frontend maps the JSON payload dynamically onto these high-fidelity visual cards, triggering custom vector animations based on whether the computed result is high or low risk. Next is our text semantic journal. Users can write down their daily narrative reflections freely. Upon submission, the frontend fires an asynchronous HTTP fetch request to Noor's transformer model endpoint. To ensure the application is completely crash-safe, I authored strict fallback validation logic. If the backend payload encounters missing keys or network delays, the frontend catches it gracefully without breaking the UI. Once saved, the data is pushed directly to Cloud Firebase Firestore, which I successfully configured using secure read-write rules. If we navigate to our Insights Logs tab, the frontend dynamically fetches the historical telemetry stream from Firestore. Using the recharts library, these string logs are translated into numeric stability indexes, rendering this fluid, animated area chart that visualizes long-term psychological trends live. We also added a System Canvas theme switch in the Settings tab for premium user customization. Everything is fully integrated across our structured development workflow and successfully merged into our master production branch. Thank you for watching our demo.